Yeah, so like she said, my name is Natalie Hahn, and I am a current aerospace engineering senior at Embry-Riddle Aeronautical University in Daytona Beach, Florida. I currently am out in Wichita, Kansas as a engineering stress intern with Spirit Aerosystems, and I've previously worked with Rockwell Collins and the Boeing Company. Outside of the many things I do for my job, I am the SWE Leadership Development Program Coordinator for the beginner track for FY21, so this year. And then I am also an RTC Fellow. I am a Harvard Business School Scholar for the summer. I hold multiple presidencies and vice presidencies at my university, and I do just about everything and anything that you can imagine. So that's a little bit about me. Yeah, so aerospace engineering is super fascinating because so much is underneath it. So anything that flies through the air is basically a part of aerospace engineering. So we do helicopters, we do the airplanes you fly on with like United and Delta, we do the big SpaceX, Crew Dragon capsules, we do satellites that have to, go into orbit and then orbit the Earth. We do a whole lot of things. And what's really, really great about it is that military and defense is also a part of aerospace engineering, which I think personally is very unique to our field. We have commercial, which is, you go to the airport, you buy a ticket, you get on a plane. That's commercial aerospace engineering. And then we have military, which is my sector. So all of your fighter planes and all of your missiles, that is the military portion of aerospace engineering. So I am maybe a little bit more of a unique situation because I had no idea what I wanted to do. When I was 3 and 4 years old, I loved looking at space and I loved looking at the stars. I loved looking at planes with my mom, and I always loved it. And at the time, the space industry was pretty much dead, and I was told there's no real way to do anything in space right now. So I forgot about it. I went through a bunch of different careers, and what really stuck with me is I always loved math and science. And I come from a very small farming community up in Ohio, and science and technology and math really wasn't the forefront of what my school was concerned about. So we had very, very basic science and math classes, with the exception of some cool things like AP biology. I didn't know what I wanted to do. So I Googled, and I Googled, and I Googled, and I realized that there was jobs in space and planes, and it was aerospace engineering. And there's a lot of misconceptions about what engineering is in general. A lot of people apparently think of like a train conductor. Everybody thinks of the person with the wrench and the fancy hat that goes and they fix things and they move on. But engineering is so much more. Engineering is all the way from the design of these brand new ideas to actually getting it in a computer design program and designing it, to making sure it's going to work, like stress analysis, like me, and then it's actually building it, and then it's maintaining that product. And I come from a very, very big military family. All 5 of my great-great-uncles were 101st Airborne in World War II, and both of my grandfathers served in Vietnam. So military is always something I wanted to do, but my health isn't the best, so I wasn't able to. And with aerospace engineering, I was able to combine my love for planes and my military lineage and the fact that I love science and math all into one, and it has been the best decision of my life so far. Definitely. Aerospace engineering is not easy. And that's one of the hardest things about my career is engineering already is kind of difficult. You're constantly problem solving. You're constantly trying to find answers to questions that nobody has asked before, and it's really difficult. But we also do so much math in what we do that it can be really, really rough. Even for me, who loves math and has a math minor, it can be really difficult. We deal with equations with 20 plus variables in it. We do a lot of physics. I mean, if you think about trying to get a plane from sitting on the ground to 35,000 feet in the air, that's a lot of different physics and a lot of different equations you're going to have to look at. But honestly, anybody that is passionate about science and math and engineering as a whole, aerospace is an absolutely phenomenal field because we are developing the cutting edge technology that's going to get us to Mars. We're developing the plane that can get you from New York to LA in 30 minutes. We're developing, you know, technology that keeps our nation safe. It is a fun, exciting field that is ridiculously innovative and is such a thrill to be a part of. I think the biggest challenge I personally have found, there's two biggest challenges, because the minute I said that, I thought of another one. The first really big challenge is making sure your voice is heard. A lot of times, teams that are one background, so mostly male, have a lot of the same thought process. You see differences, but a lot of times they think the same way. They're used to running things a certain way. They're like the well-oiled machine that just keeps going. And when you are one of the only females on the team, or even in the office, like my current office, I'm one of 3. It can be really hard to feel comfortable with speaking up and speaking out when you have ideas or questions. So that's definitely one of the big challenges. And then I think personally, for me at least, another really big challenge is feeling like you belong. And this is for all minorities, you know, because I'm also a member of the disabled community, and I'm also a member of the LGBTQ community. When you look around and you don't see anybody that looks like you struggle. Do I belong here? Am I smart enough to be here? Nobody else looks like me. Is that because nobody else like me is able to do this? And the answer is no to all those things. I'm perfectly capable of doing it. I'm meant to be here. I'm smart enough to be here, but it can be really disheartening. But that's why there's amazing organizations like the Society of Women Engineers, where at my school, I have an amazing group of like-minded women who have had a lot of the same experiences. And it's not just women. You know, there's NSBE, which is the National Society for Black Engineers. There's SHEP, which is the Society for Hispanic Professional Engineers. There's all these amazing organizations that have come from people that feel not the most comfortable or deal with areas where they question if they belong. They are used to being the only, you know, female in the room who's disabled and a member of the LGBTQ community. So as hard as it is and as horrible as the misconception, I mean, the stereotype, it's not a misconception, it's definitely true, is there's a lot of amazing organizations that are out there to change it and to balance the gender and the racial and the ethnic diversity groups in engineering, especially aerospace engineering. We're seeing a lot of that change start to happen. So it's getting there. Yeah, so my first recommendation is don't second guess yourself. If this is something you want to do it. You will be fine. I do not have the strongest science and math background, as we've already kind of spoken about, and I'm doing phenomenal right now. 3 internships under my belt, multiple leadership positions, and I'm at the #1 university in the world for my degree. Shout out to Embry-Riddle. So don't question yourself, okay? Once you get to where you feel comfortable and you're in college and you're ready to go, an amazing organization to look at is AIAA, which is the American Institute for Aeronautics and Astronautics. And they are the country's premier aerospace organization. The resources they have are incredible. The awards and the scholarships and the competitions are phenomenal. If you're going to any college with aerospace engineering, I guarantee they have an AIAA chapter at your school. So, you know, don't be afraid, reach out, go to the meetings, join the groups. It's really cool because AIAA is one of the few organizations that has the professional side, but also the hands-on project sides as well. They have an amazing competition called Design, Build, Fly that you can take part in. So AIAA is an amazing resource, but another amazing resource that a lot of people don't think about is your professors. Go to their office hours, bug them, see what their industry experience is, see what their research experience is, because there are some phenomenal professors out there, and not even professors that are AE professors. One of my favorite professors at my university was my thermodynamics professor, and he worked on the F-15 as a mechanical engineer, which is my personal favorite fighter jet of all time, until the one I designed. So talk to your professors, see what their experience is, and learn from them, because that's really going to help kind of move you further when it comes to networking and getting your foot into the aerospace industry. Yeah, so I actually got my job at the organization I mentioned, their society conference, the Society of Women Engineers. Spirit Aerosystems was at the career fair, and they are the world's premier structures supplier for Airbus and Boeing and a bunch of different military projects. And I knew, being interested in structures, that that was the company I needed to go to get my foot in the door and understand what structures and engineering was really like. So I went, I applied, interviewed, got accepted. I'm very thankful they were able to keep their internship program this year, considering everything going on with the pandemic. So I'm actually out here on site. So every day I go to work as a stress engineer with the Advanced Product Development Group. So this group is on the forefront of Spirit Aerosystems technology, which is super exciting. What it means is I can't really talk too much about it. But what I do on a day-to-day basis is I utilize software and programs to look at parts of an aircraft and go, okay, so if we were to design this piece in XYZ ways, and we apply the loads that an aircraft goes through when they are flying through the sky, is the part going to survive or is it going to fail? And if it survives, the next question is, how can we make it cost effective? How can we make it weigh less? Are we sure that this is the best design possible? And if it fails, now we have to figure out why. And that's a whole other set of programs and softwares and analyses to figure out, okay, it failed, but did it fail because of the way we designed it? Is it the material we chose? Lots of different things. And my particular group deals a lot with composites. So composites are the next forefront of aerospace technology. They're being used a lot right now already. But basically what it is it's two materials woven together to make an even better material. And there's all sorts of brand new composites always coming out. So my team uses composites a lot to figure out, okay, is this going to weigh less? Is this a stronger material than what we're currently using? It's a lot of fun. It is the definition of being an engineer. It's problem solving every single day. It's using equations I actually see at my university in class. Day one, I opened up a PowerPoint and I was like, I know what the Tresca failure theory is. It's literally my class. So it's 8 hours of problem solving and figuring out how can we do better. And it can be hard at times. It's definitely not the easiest job in the world, but I wouldn't change it. I'm in love with what I'm doing here. So my experience with COVID was not the best. So my school, we were on spring break when they came back and said, yeah, we're gonna keep you guys at home for the next month. And then they came back and said, we're stopping in general. But I have a little brother who has disabilities. So I had been quarantined since the beginning of March. And I was not going anywhere because he would get very sick if he were to get COVID. So my first time truly going anywhere was to this internship. And it was right at the height of the aerospace industry really starting to struggle with COVID. It had been 2 solid, probably even 3 solid months at that point with the industry losing tons of money. And I came to my company right after a bunch of layoffs happened. It's disheartening. It's hard because you love your industry so much and you see what's going on and you know that there are really intelligent people and really amazing people that are losing their jobs and there's really nothing you can do about it, and it's hard. It makes you very thankful as an intern, as somebody who is still here, to have the ability to still be here. In terms of the industry, what I will say, and in terms, you mentioned people possibly changing their career fields or changing their industries. Unfortunately, what we're seeing now is really unprecedented. But what it's showing us is that every industry is struggling. It is not just aerospace. It's aerospace, it's medical, it's automotive, it's everywhere, is really, really struggling right now. And I think, at least when it comes to aerospace, we're really lucky. And the reason for that is I mentioned that we have all these different components of aerospace. We have commercial, we have military, we have, you know, helicopter, commercial, helicopter, military, plane, commercial, plane, military. We have space with satellites and rockets. We have missiles. The aerospace industry is really, really vast. And this is really great because what it means is even though right now commercial is struggling, companies are getting more defense contracts than ever before as the current administration ramps up efforts to continue to build up our military. It is things like SpaceX and Blue Origin that are doing, you know, private space work that's never been done before, that is growing at a ridiculously fast rate. There's a lot of opportunities still in aerospace engineering and the aerospace sector in general, because you don't have to be an engineer to be in aerospace, which I feel like I always want to point out, because engineering is really, really difficult. But if you love, you know, space and flying, you can still be in the sector. So don't let that discourage you either. It's expected to go back up within a decade, but it's not going to be the easiest time. But I think when you're passionate about something, you make it work. You know, if it means that when I go to graduate, I have to take an internship or a full-time job with a mechanical engineering company and it's mechanical based before I can get back into the aerospace sector, that's what I'll do. But it's unprecedented, and the companies aren't necessarily sure what the future holds. Universities aren't sure what the future holds. But I will say, if you are high school freshman or high school senior, and you know you're looking at this, go to a community college, get some credits out of the way, and see kind of where the industry takes us and see where universities takes us, and just one day at a time. That's all we can do. One day at a time, one step at a time, and we'll get through it. The aerospace sector has been through a lot before. The commercial aviation has been through some really, really rough spots before, but we'll get there. We got this. Just like every other industry, we got this. Yeah, it's a lot broader than anybody can really, you know, think of. And it was something that with my limited experience and knowledge, when I jumped feet first into my degree, I wasn't able to go look at my school. I had to choose my school blindly based off of reviews and what I had heard and what I had been offered. I had no engineering experience. I had no aerospace experience. I had never been on a plane until I got on the plane that would fly me from Ohio to Florida to learn how to study to build planes. And it's, you know, you don't have to have the most background ever, and I had none. And I walked in not knowing anything about the industry, not knowing anything about what I wanted to do other than, okay, it's aviation, it's military. If I want to go space, I can, let's go. I still find areas where I'm like, liaison engineering, what's liaison engineering? And it's people that in the factory, when something happens on the production floor, they figure out how to fix it so that you can still use that part or you can still use that plane. So I'm still learning things, you know, so that's a really cool part about engineering. You don't have to have the most knowledge ever to jump in and go to school and do it. And you're constantly going to be learning more and more and more about what it means to be an engineer, which is fascinating to me because you think eventually you know it all, right? And that, especially aerospace engineering, there's always something new that sneaks up on you and you're like, wow, you learn something new every day. Yeah, so that's actually a question that every year at my school I get asked at least once by a professor. Like, what do you think the future of aviation holds? And so we've seen a lot of innovation recently. And one thing I want to call out is at Boeing, they have the 777X, which has been doing flight tests and is hopefully going to get into service. And they have this really cool thing where the wing tips actually fold in. So like if you have a straight arm, the tips of the wings go because the plane is so massive, it can't fit in airport terminals that currently exist. So they went through all this certification engineering to create a brand new type of wing that literally folds up. So we see a lot of innovation and a lot of really, really new exciting things happen all the time in aerospace engineering and in aviation. I think one field that is really going to start jumping out at us soon is using new materials for aerospace. There is a material that the name of it escapes me for right now, but you can take a coil of this material, like a spring, and you can deform it as much as you want, and you can stretch it out. And if you apply heat to it, it shrinks back and reforms into its original shape. And they're currently looking at possibly using this on aircraft. So they could make the original plane smaller, and then as it heats up, the plane would actually, the nacelle, which is what holds your engine, could actually expand to allow for better aerodynamics and heat flow and all sorts of crazy things. And then when you land, it could shrink back. It is super cool. Their materials are going to be the new age of aerospace, you know. There's also a lot of really, really cool companies like Boom Supersonic, Aerion, Hermeus, who are working on making a quiet supersonic aircraft. And this could get you from New York to LA in under an hour. And there used to be a plane called the Concorde that did this, but the Concorde was super noisy. Every single time it went overhead, you heard boom, boom, and it was ridiculous. And they stopped flying it because of noise complaints. And they're currently looking at, okay, well, how do we utilize the shape of the aircraft to make sure that supersonic boom, which is that boom, boom, doesn't happen? And we can still use this type of aircraft. So we're looking at things like noise reduction through the shape of aircraft. There's also a lot of push to get green aircraft. In fact, Boeing just signed a contract where they are going to be working on figuring out some green technologies for commercial aircraft, so we can cut down on, you know, carbon output, and we can work on noise reduction, and we can start becoming more environmentally friendly in the aviation industry because of how many planes every single day go off. And there are some companies like Rolls-Royce that are already doing this, where Rolls-Royce has an engine that is extremely eco-friendly when compared to other aircraft engines, but constantly trying to push, you know, how do we become a better friend to our environment? So there's a lot out there. I think personally what's most exciting for me is the shape of aircrafts, because I want to be the engineer that creates the next elite fighter jet in the country. I want to be that person. And I think a lot of that's going to come down to the shape and how fast I can get it to go. So that's what really excites me. I definitely think it's possible. I'm not sure how soon it's going to be possible, but I think that, you know, we're seeing it with cars already, you know, where we're starting to get a lot of that, you know, electricity, and they're starting to look at, I know there's a gasoline being created out of algae. There's all these new exciting ideas, and I think that that's very easily transferred over to aviation. So, you know, you use jet fuel. You know, at Embry-Riddle, we joke and we have a shirt that says, I love the smell of jet fuel in the morning, because my school is connected to the Daytona Beach Airport, and we have our own fleet of aircraft that's just everywhere. It's massive. And so that's the big joke, but I could see possibly using a new type of biodiesel or anything created out of algae to replace that jet fuel and be more, again, environmentally friendly to our Earth. I think it's definitely possible. I know they're also looking at electric aircraft, so kind of like you have your Teslas and your electric cars. My school actually has a really, really cool research project on electric powered aircraft. So I think it's possible. I would say the next decade. I think you could start seeing it become more readily available. I'm not sure how quickly it's going to become readily available on commercial aircraft like United and Delta planes. But I think at least for smaller planes like Cessna's two-seaters, I definitely think that's a possibility in the next decade. Sure, you're definitely closer. I personally have not heard of anything that is being done like that. I'm sure somewhere out there at like MIT or Georgia Tech, or probably even my school, and I don't know it yet, they're definitely looking at that. I believe they've started that with drone technology. And usually, especially nowadays, that's kind of the first step, because drones are a part of the aerospace industry. You know, they fly through the air. The FAA, which is the regulatory body for aircrafts, they have a whole section now about drones and where you can fly them and what licenses you have to have and all sorts of cool things. So I know they've started that with drones. So my guess is that aircrafts are coming up real soon. I'm sure, like I said, I'm sure there's some project out there that's doing it and I just don't know about it. But that, you know, that's a big challenge with aerospace in general in the industry, is it's so large that a lot of times you're like, oh goodness, I didn't even know that was a thing. I didn't know they were looking at that. And there's because there's so much going on that sometimes some things can slip underneath the radar. So. Ooh, that's a good question. I think my response is not necessarily about aerospace specifically, but about STEM. I wish I would have known how few women there were in STEM. My school, you know, I was one of the only women that went into a field that wasn't medical or, you know, like nursing and doctors or teachers. I was kind of the oddball at my school for the fact that I wanted to do engineering as a woman. And I never really thought anything of it because, like, I'm in this super small farming town in Ohio. Like, the likelihood I'm the only female to me wasn't, you know, surprising. A lot of my classmates were really passionate about medicine, so I was kind of expecting it. And then I got to Embry-Riddle, and at the time, only 19% of my university was female. And it was an even smaller percentage in aerospace engineering. And it really threw me for a loop really, really quickly. You know, it was like, wow, there's not a whole lot of females. I was in an engineering 101 class, and out of 33 people, I was the only female. The only other female in the room I saw was my professor, who happened to be a female. And as I would find out later, my TA was also a female. So 36 people, 3 are female. I think it would have just helped me come in with a better mindset, because for a while, I really, really pushed myself harder than I should have, to be honest, because I felt like because I was one of the only females, I had to continually prove that I was better. And when I didn't feel like I was performing the best or I wasn't the highest grade, I took it really hard. And I think just knowing what the stats were in general for STEM would have made me realize, you know, it's okay because I'm smart enough to be here at all. I don't have to constantly be proving myself. And once I kind of took a step back and started being happy about my grades for myself and being happy about my projects for myself and not comparing other people, my grades went up and my happiness went up. And that meant everything else was positively impacted. So I think looking back, that's the one thing I wish I would have known. Because you can always learn about the industry. You can always learn more specifically what it means to be an aerospace engineer or an engineer in general. But having something that stark thrown in your face that quickly threw me for a loop, to say the least. So right away, 2 really, really big things come to mind. The first one is make sure you are truly passionate about this field. And it's okay if you get to school and you realize you're not as passionate as you thought you were. It's completely okay to change majors. And that's something that I think as a society we don't do super well of, is promoting the idea that if you get into a college degree and you decide it's not for you, it is 1,000% okay to change majors. And with aerospace engineering, it is very, very competitive. It is a very, very tough field. And it is very heavily technically focused. So make sure you're really passionate, and if not, have no shame in changing majors, because I have seen, you know, aerospace engineering really takes you for a ride. And sometimes the ride is horrible and it means you're crying in the university library at midnight, which has happened to me before. And it's okay to admit that it's happened to me before. And then sometimes you are so happy with what you're doing that you're rushing home to your parents at the end of the semester going, look at this amazing project. I know you guys don't understand it, but I have to show somebody and I'm showing you guys. Make sure you're passionate. And again, it's okay if you're not and you get in and you're like, not for me. My second really, really big piece of advice is know how to study. You know, I came in again with no physics background, past my one little semester class at school. And I came in with not the best math knowledge. I only took basic calculus and I ended up retaking calculus in college to make sure I was ready. But I thought I was your AP extraordinaire. Out of the 7 classes I took in high school, 6 of them were AP. And I made sure of it. And I was very excited to make sure of it. I even took AP art. Like, I took pretty much a full AP course load. And I waltzed into college going, I know how to study. I've got this. Like, isn't that what these AP classes are supposed to teach me, is how to study and how to be a collegiate student? And turns out I was wrong, very, very much. My first failure on an exam, I took very, very roughly. And I was very, very upset for honestly much longer than I should have been. And it all came down to I didn't know how to study. I was so used to, in high school, having things come naturally to me that when I went to study at home at night, it was, my studying was reading through and going, oh, I know this, and then acing my test left and right. At college, you're not going to know anything. Fun fact. And even when you think you're going to know something, you're going to get thrown for a loop because you may genuinely not. So knowing how to study and having productive study sessions is so, so important, because I have very genuinely read a book for 4 hours and still not understood what the heck I was talking about at the end. And studying effectively is not just studying by yourself like it is in high school. It's studying for tests with your classmates in a massive circle in the library. It's bugging your professor every single time they have office hours because you need to understand the material. It's going to tutoring sessions and tutoring labs. There's no shame in that. I think, again, as a society, especially in high school, we promote this idea that you have to do it alone, that you have to be able to understand all this by yourself. And if you get a tutor, man, you obviously don't know what you're talking about. In college, it's completely different. Use your tutors. There is no shame in it. One of my friends is probably the smartest human being I have ever personally been able to speak to. And even they go to tutoring sessions, and they go to supplemental instructions, and they go and bug the professor about, I don't understand this one problem, and lo and behold, that will be the problem on the test. So understanding how to study effectively and utilizing your study resources, I'll add in that asterisk, is going to set you up the most for success. It's great if you have lots of physics backgrounds from high school. It's great if you have lots of math backgrounds. It's great if you can even get into some engineering classes in high school, and if you do things like first robotics. But speaking as somebody that had none of that, speaking as somebody that had no mentors in high school for what I'm doing now, speaking as somebody that didn't even know what aerospace engineering was until a year before I applied for schools, you can do it. Just, you know, you don't have to have all that stuff. Know how to study effectively. That's the big one. I will say in college, you know, especially my first year, I felt very much the same way. I was embarrassed to go to office hours. I was embarrassed to admit I didn't know it. What I'll say in regards to that is they're not expecting you to know it. And if you know it, why do you not already have a degree, right? You're not expected to know it. And what I found to kind of help me get over that fear was, first of all, acknowledging that professors in college, a lot of times they have like a class in the morning, then like research in the afternoon, or they have multiple classes throughout the day, when they're holding office hours, it's because they're already on campus and they're already there. So it's not like you're forcing them to stay later or take time out of their days. They already have to be there anyways. And I know like my school requires professors to hold so many office hours based on how many hours they teach. So you're not forcing them to be there any later, which is really nice, because I felt the same way in high school, like, oh, you have to stay later because of me. Not the case. The nice thing as well that I started doing my end of my freshman year and into my sophomore year is have a buddy for office hours, because I was always so embarrassed to walk there alone and be alone in my office hours with my professor and acknowledging I didn't know what was going on. It always just felt awkward to me. So I would literally grab whichever friend was closest and be like, fun fact, you're coming to physics office hours with me, even though you're not in this class, because I just need somebody to come with me. And over time, you start getting adjusted to office hours in general to where you can start going by yourself. So if you're nervous about it or you're not sure what's best, I recommend a buddy. 1,000%. So the cool thing about aerospace engineering is the fact that it's part of the aerospace sector. And the aerospace sector requires a ridiculous amount of people to help it run. You need business people to run your teams. You need, industrial engineers to make sure your products on your manufacturing floor are going as fast as possible. You need safety people. You need air traffic controllers in the aerospace industry. So it may not be necessarily that you can get involved with aerospace engineering itself. Aerospace engineering is very, very technical. It requires a lot of education and a lot of different courses, and a vast amount of aerospace engineers actually also have their masters. Which is something that I'm going to be doing, is getting my master's. But for the aerospace industry, 1,000%. In fact, my school is pretty unique because like our business programs, you can do things for like airline management, where your business degree is centered around learning, how to run an airline. There's our civil engineers. There's one for like airport construction, where you learn how to build like taxi runs and tarmac for aircrafts, so maybe not aerospace engineering specifically, but the industry, yes. Every sort of major is needed in the aerospace industry. Yeah, so the cool part about aerospace engineering is you do not need your master's to go into industry. So a lot of schools are a 5-year degree for aerospace engineering. My school offers a 4-year degree, but a lot of times, pushing back classes or getting co-ops and internships will kind of push back your graduation date. But you can go straight from a bachelor's in aerospace engineering to your industry. And what's really nice about the aerospace industry is a lot of times for aerospace engineers, your company will pay for your master's. So it is very, very routine for people to start at a company with their bachelor's and get their master's while they're working, and sometimes even get their doctorates. Usually when you get a master's in aerospace engineering, it's because you want to be even more specific. So kind of the basis of aerospace engineering is mechanical engineering. So it's like mechanical, then you specify down to aerospace. And then when you get your master's, you're going to concentrate in one specific area of aerospace engineering, which makes you even more specific and specialized. So usually that's why people get their master's a little bit later as engineers, is because they go, okay, I want to work 100% with dynamics and controls. I 100% want to work in structures and stress. It's, like I said, it's very common, but it is not needed. If all you want is a bachelor's in aerospace engineering and you don't want to be super specialized and you want to spend your life as an engineer, you're good. A lot of times people also get higher levels of educations to become technical fellows or managers. So like, for example, I know I definitely want to become a manager one day. I love leadership. I love leading teams. I love working with people. But I also want to get a lot of experience technically first. So I'm looking to get my master's in a specialization of aerospace, which I'm still trying to figure out if that's structures or aerodynamics. And then eventually I'll also get my MBA so that I can be, you know, more knowledgeable on the business side of things so that I can be an effective manager. Yeah, so AIAA is definitely the really, really big one. If you are a female in aerospace engineering and the aerospace industry in general, there's also WOA, which is the Women of Aeronautics and Astronautics. And there is also Women in Aerospace, which is WIA. And then there is a really, really great organization called Women of Aviation. And they do a lot. It's not as much, aviation is a part of aerospace. So it's very plane oriented compared to, like, you know, helicopters and rockets in space. But they're also a really, really phenomenal organization that has a lot of outreach to younger kids in K through 12, which is really great. Additionally, you know I mentioned the Society of Women Engineers, but there are a ton of different professional organizations that, even though they're not aerospace focused, would be really, really great to join because they're going to give you the professional networking and knowledge you need. So SWE is definitely one of those. There's also NSBE and SHEP, which are respectively for Black engineers and for Hispanic engineers. There is also organizations like Tau Beta Pi, which are honor society organizations in engineering, which that gives you incredible reach and incredible networking opportunities as well. So really any professional-based organization for engineers, if you're an aerospace engineer, would be really, really beneficial. I have a very, very strong preference for SWE. I will talk about SWE all day. And in fact, SWE actually has a high school version called SWE Next. So if you know for sure you want to be an engineer and you are a female or you identify as female, because we do, you know, there's non-binaries and transgender and everybody. So if you identify as female, or even if you're an ally, so if you are a male but you really, really believe in making sure that engineering is diverse and equal and that everybody is represented, you can also join SWE. And SWE Next, which is the high school version. So I could probably talk all day about SWE, but definitely, like I said, any professional engineering organizations, AIAA, WOA, WIA, all those organizations. There's a lot out there. There's a lot of really, really great communities with like-minded people that you can join. And I'm sure even more as you look at individual schools, and you start looking at, you know, colleges and what special organizations they offer that maybe don't have a national or society attached to them, you're going to be in very, very good hands. I know SWE for sure has that high school. I'm not sure about NSBE or SHEP. And it's not, let me clarify, you know, it's not just Black engineers and Hispanic engineers. There's also one for Asians and Pacific Islanders. There's one for Native Americans. I mean, any sort of minorities that you can think of have a professional engineering organization out there. And if they don't, start one. And I'm sure many of those have a high school component to them. I'm just not super knowledgeable about that part outside of SWE. Yeah, so imposter syndrome is something that is near and dear to my heart. So I actually, funny you mentioned this, just the other night had a very, very big cry session with my mother because I felt like I wasn't doing enough. And it was imposter syndrome rearing its ugly head in all of its glory. Imposter syndrome is something that is very, very hard to deal with. And if you are dealing with imposter syndrome, I'm very genuinely sorry. I didn't know other people never dealt with imposter syndrome. And for anybody that doesn't know what imposter syndrome is, it's basically the feeling of no matter what you do, it's never enough. You're never good enough. You're never far ahead enough in the game. You're never achieving what you're meant to be achieving. You're always on the bottom of the totem pole. And I was amazed to learn that there are a lot of people out there that never have these feelings and these thoughts. My friend Tyler is a phenomenal software engineer, and he has never dealt with these, and it amazed me. I thought everybody did. So if you're dealing with imposter syndrome, I'm very, very, very sorry, because I know how hard it is. I know how horrible it can be. And it's taken me a really long time to learn how to manage it. And sometimes I don't manage it, like the other night, where it was just so bad that I had to call my mom and cry. My mom is my rock. But what I found over the years is the best way to combat imposter syndrome is nothing you can actually do. My favorite thing to do is talk to my friend, any of my friends, and go, here's what I'm doing. What do you think? And you don't say anything more. You don't tell them you're dealing with imposter syndrome. And the amount of times I get people that go, oh my goodness, you're doing so much more than I ever could. Or, oh my goodness, I can't believe you're achieving those things. Those are amazing. Or, oh, I can't believe you have that many public speaking engagements. Hearing the positive feedback from my friends made me realize that even if I'm not winning the most awards, or I'm not, I don't have the highest number of volunteer hours or whatever it might be, that I'm still doing incredible things. And that's something to keep in mind, is it's not what you do or how much you do, it's the quality. It's kind of how I view, my presidency with SWE, because I'm a past multi-term president with the Society of Women Engineers at my school. It was never about how much we were doing, but the quality of what we were doing. If we could do both, that's great. But what's better? 10 outreach events with only 10 people, or 2 outreach events with 100 people per each one? It's never about how much you're doing, it's about the quality. So if you can sit back and get positive reinforcement from people and look at what you're doing and going, this is fantastic. This is benefiting me, this is benefiting others, this is incredible. I think imposter syndrome is a lot easier to deal with, because realistically, as hard as it is to fathom, there is always going to be somebody out there better than you. And this is what my parents told me in middle school and in high school, because high school is when a lot of my mental health problems started and a lot of when my imposter syndrome started. They told me there's always somebody that's going to be better than you. There's somebody that's going to be smarter than you. There's somebody that's going to be prettier than you. There's somebody that is going to have more awards than you, more community service hours than you, more leadership positions than you. But what does it matter? Because in the grand scheme of things, the only thing that matters is you and your happiness and what you personally are achieving, and if you're happy with it. So instead of looking at it from a big picture, focus just on you. Because realistically, it doesn't matter what the engineer next to work is doing to you. You may not even know that person in 10 years. It doesn't matter what this person you've never heard of on the internet is doing, because realistically, what's important is you and what you're doing and who you're benefiting and where your happiness is. And very genuinely, and Gina, I'll say this, if anybody wants my contact information or my LinkedIn, and you want to have more of a conversation about imposter syndrome or mental health problems while you're dealing with this, please reach out to me. A lot of people make the mistake of thinking they can combat imposter syndrome alone, and you can't. Like I said, positive affirmations from friends, cry sessions with my mother. Don't do it alone. You shouldn't have to do it alone. And if I can be that resource for anybody, please let me know. So I've mentioned this a few times today, but I'll mention it one last time, because I think it's really important to kind of close out with. I went into the field thinking it was just planes. I was like, oh, it's just planes, it's fine. Like, I knew space existed, and I knew space was part of it, because that was part of my awe and amazement, but it seemed like the main sector was planes, and that was 95% of it was planes. And then I got in and I realized helicopters were included. And then I realized that missiles we fire at other nations, are considered aerospace because they, fly through the air. Even things like submarines. because they move through a fluid. It may be marine engineering, but it's a lot of aerospace engineering too, because aerospace deals with aerodynamics, which is just the movement of a body through a fluid. Water is a fluid, air is a fluid. So even things like that can be included and can need aerospace expertise to solve. It's so much broader than I ever would have thought. Satellites, GPS, the satellites that give us GPS and allow us to, find our way from here to our friend's house is aerospace, because we have to launch them. They have to orbit the Earth. It's so broad. I'm very, very lucky that I love planes, and I'm very, very happy doing planes. But there is so much to it. And, it was mentioned earlier, all the brand new innovations and technologies that are happening, it's only going to continue to grow. Drones 15, 20 years ago weren't anything, right? Well, now the Navy is using, and the Air Force are using massive drones to do surveillance and to do, to drop missiles. If you want to know something really cool, look up the Boeing MQ-25. It's a massive naval drone that they're using. And I mean, that's a brand new, very exciting field of aerospace engineering. And it's only going to continue to grow as we have more capabilities to do things and we have new technologies and new innovations. So that's the one thing I wish I would have known. It's not just planes and like 5% of space. It's more like 2% of a ton of different things, which is super cool. Thank you guys so much. I love talking about my field, and like I said, if anybody has any more questions, comments, concerns, you just want to know more, all of my social media has my name, Natalie Hahn. Find me on LinkedIn, get my email from our lovely host here, and reach out to me. I'm more than happy to talk for another 20 hours if I have to about my field, my school, and what I do. So thank you again so much.
Thank you too, and have a good rest of your day.
Thanks.
Bye-bye.